Let's try another example. Let's say we have a 0.5 molar solution of hydrogen peroxide, which has a pH of 5.96. And the question is, what is hydrogen peroxide's pKa? That's right, hydrogen peroxide can be an acid. We don't normally think of it as an acid because it is so reactive that it reacts before it has a chance to be acidity. But it is an acid. It does have a pKa if we can keep it from reacting. So we're dealing with an acid because we're talking about pKa. So what do we know? Well, we know if we're going to set up the acid, weak acid equation, okay, we know that the H2O2 is the acid, therefore its conjugate acid will have one less hydrogen and one less positive charge or one more negative charge than the acid, okay, and that H2Os are the reactant and it will give us H3O plus, okay. We know that we have an initial concentration of 0.5 molar and we have an equilibrium pH of 5.96. So let's find the concentration of H3O plus. That will give us 1.1 times 10 to the minus 6 molar. So we know we're going to initially have 0.5 molar H2O2 and none of the conjugate base or the H3O plus. When we go towards equilibrium, we are going to change those concentrations, and at equilibrium, we know that we have a pH of 5.96, so our concentration of H3O plus and X is equal to 1.1 times 10 to the minus 6. Okay, now let's plug all the information in. Therefore, our Ka is equal to x squared over 0.5 minus x. Solving for the Ka, we get a Ka of 2.4 times 10 to the minus 12, and thus our pKa, which is the negative log of Ka, is 11.62. All right?